Hello, today we're going to talk about the different types of chemical reactions. There are 5 that we're going to discuss in this unit, and they don't incorporate every kind of reaction you could encounter, but it is the vast majority of the different kinds of reactions that we have in nature. All right, so the first one is called a combination, or sometimes I'll refer to it as a synthesis, so you should be able to use those interchangeably. And basically the general form of a synthesis reaction or a combination reaction is you have 2 separate reactants that come together to make one product. All right, so when we just show them as letters like this, it's relatively easy to recognize, but when you're looking at actual chemicals and equation, it might be helpful for you to remember that you always have 2 reactants and just one product. If you just have one product, you've done a combination reaction because you've combined everything that was on the left and put it into one thing on the right. All right, the opposite of that would be a decomposition. We start with one compound and we end with multiple pieces at the end. So we break it apart or decompose it. All right, so to recognize that one, again, one reactant, and you'd have at least 2 products that form as a result of that reaction. All right, the next is single replacement, or sometimes I'll call them single displacement. It's the same thing. In these kinds of reactions, you start with a single element and a compound, BC in this case, and A comes in and replaces one of the things in the compound that you have. So that now, B, which is the thing it replaced, is by itself, and A is now paired with C on the other side. So this is always 2 reactants and 2 products, right? And you'll always start with an element and an ionic compound, and you'll end up with an element and an ionic compound. So this is part of the reason we spent so much time understanding the difference between ionic and covalent compounds, because if you can recognize them, then it's going to make it easier for you to recognize different types of reactions. All right, double replacement or double displacement. We have 2 compounds, all right, and we basically have a partner swap that happens. So A comes in and replaces C, switches places with it. So now A is paired with D over here, and C and B are paired with each other on the other side. All right, so we always have 2 reactants and 2 products in these kinds of reactions. And it's always 2 ionic compounds forming 2 different ionic compounds. And then the last type is a combustion reaction. So the general form of these is we have something with carbon and hydrogen in it, right? We have oxygen gas, and we always form CO2 and water. So the general form is a hydrocarbon. It's just a general name for a compound that contains carbon and hydrogen, oxygen gas, and we always make carbon dioxide and water, and then a lot of heat. So pretty much any burning reaction that you know of is a combustion reaction. All right, so now let's practice identifying which is which. All right, so in our first one here, we have AgNO3. Ag is a metal. All right, NO3 is one of our polyatomic ions, so this is ionic. H and Cl, H plus is an ion and Cl minus is an ion, right? And then the H and the Ag are switching places here. So the Ag is now going to pair with the Cl on the side, and the H will pair with the NO3, right? So this is 2 things swapping partners, all right? So that's going to be a double replacement reaction. Here we have mercury oxide, and we're making mercury and oxygen. So we had 1 starting material, 1 reactant, and we made 2 products. So we must be decomposing it. So this is a decomposition reaction. Our next one, we have zinc metal, and we have HCl again. All right, the zinc on the other side is now paired with a Cl, and the hydrogen is all by itself. Okay, so we had an element and an ionic compound, making an element and an ionic compound. So this is going to be a single replacement. Here we have carbon and hydrogen reacting with oxygen, and we get CO2 and water. So whenever those are your products, you should know immediately that's a combustion reaction. And then our last one, we have 2 elements, sulfur and oxygen, and they come together to make one product. So this must be a combination reaction. All right, now that we know the different kinds of reactions, we should be able to make some predictions about what products will form. All right, so in this first one, we're doing a combination. So we know that everything that's over here on the left is going to form one compound on the right. Okay, calcium is a metal and bromine is a nonmetal. So when they come together, we're going to make an ionic compound. Because we know metals and nonmetals make ionic compounds. So Ca, you'll have to look at your periodic table. It's in column 2A, so it's going to have a positive 2 charge. And bromine will have a negative 1 charge. So we're going to need 2 bromines to make this a neutral compound. So in this particular case, the subscript of the 2 from the BR carried over, but it won't always, okay? So you need to check the charges and make sure that you've made a neutral compound as your product. All right, decomposition. NaCl decomposing would make sodium metal and then chlorine gas. Chlorine happens to always be present in nature as a pair. There are 7 elements that do that. I will ask you to try to remember them, because you'll be able to get more accurate results with predicting your products. And I can help you with that in class, but just know that's why it's a 2 here. All right, so we have sodium metal and chlorine gas. All right, the next one is a single replacement. So we have a single metal here, all right, and then we have hydrogen, which is an H+ ion, and PO4, which is a polyatomic ion. So remember, I will give you the table of polyatomic ions in this unit, but if you can't recognize that this is a polyatomic ion, it's going to be hard for you to know which things need to swap. All right? So when this replacement happens, the magnesium could replace the hydrogen, or it could replace the phosphate. Okay? Magnesium, being a metal, is always going to form a cation. It's going to give away those 2 extra valence electrons. So it will want to pair with an anion. Phosphate is our anion over here. It has a -3 charge. So the magnesium will pair with the phosphate. Magnesium has a +2 and phosphate has a -3. So our formula will be Mg3PO42. All right. And then hydrogen by itself just makes hydrogen gas. That's the elemental form of hydrogen. Right? I have not balanced this, but we'll get to that. We'll get to balancing the equations after we predict products. And if you don't form the right products, you often can't balance the equation. So it's important that you think about what the charges are and what compound will form as a result on the other side. All right. Here we have a double replacement. So we have nickel chloride and sodium hydroxide. So nickel and sodium are our cations. Those are the things that have positive charges. Those will need to switch places so that they're each paired with something negative. We wouldn't want Ni and Na to pair because they're both positive, so that doesn't work. All right, so Ni is going to pair with OH. We can tell here that the nickel has a +2 charge because it's paired with 2 chlorines, which has a -1. All right, so nickel and hydroxide will make NiOH2. Right, we'll need 2 of these because it's -1. And then the sodium is +1 and the chlorine is -1, so we'll just have Na and Cl to make that neutral. Right, and then the last one, combustion ones, are almost the easiest because if you have a hydrocarbon and you have oxygen, your products are always just CO2 and water. Balancing them can be kind of tricky, but predicting the products is relatively straightforward.